Hello, this is Chapter 9, Troubleshooting the Network. Now, let's begin with an introduction to the topic. We know that if a network or a portion of the network goes down, it most surely will have a negative impact on the business. So the ability to solve any possible issues that come around the network is a very demanded skill in the IT business. And for network administrators to solve these issues in the most quick and efficient way, they have to use a systematic approach to troubleshoot these problems so that full production in the network can come back as quickly as possible. And for network administrators to properly monitor a network and solve any possible issues that may happen, um, network administrators must have a set of the following documentation, and each of them will be talked in more detail in the next slides. The documentation needed is the configuration files for network devices and end user devices, the physical and logical topology diagrams of your network, and the baseline performance level. The network configuration files are the files with the configuration from any device that is helping your network run. It's routers, switches, anything like that. And the type of information that we have in these files is the type of device, as I said earlier, what it is, the model designation of the device, the iOS image, the host name of the device, the physical location of the device, the data link and network layer addresses of the device, and in case if it's needed, any additional information about the physical aspects of the device. And the end system configuration files. These files share some similarities with the network configuration files, but as you can see by the name, those are files that contain only end user system devices. And the information that these files have is the device name, the operating system and version, its IPv4 and IPv6 addresses, the subnet mask and prefix length, the default gateway, DNS and Win server addresses, and again, in case if there is any network application that is consuming an important, let's say, quantity of bandwidth, it should be registered in here so that troubleshooting can be made easier if you are monitoring something in that device, or so you can see what is happening without having to assume things. Now, the physical topology, as its name says, is the physical diagram of your network topology. It has everything to do with the hardware that is in your network. And these diagrams contain the following information, which is the device type, the model and manufacturer, the operating system version, the cable type and identifier, the cable specification, the connector type, and the cabling endpoints. Now, these are just general descriptions that I'm naming in here, but here in the next slide we can see more of an example of what does this physical network topology diagram is about. As you can see here, it's our network. There are routers, switches, servers, and if we look closely into the diagram, we can see here, for example, this server has its name, what it is, a web trivial FTP server, and its physical location, the first rack, the third shelf. And if we move on, we can see that it's connected by this specification, the router through it's again with this specification, and so with what we saw in here, the device name, the manufacturer, the connector type, everything should be in this diagram. Of course, this type of diagram cannot hold all the information needed for properly monitoring your network, so, well, not monitoring, but troubleshooting your network. So because of that, we have also a logical topology diagram for your network. This diagram should contain the following information: your device identifiers, again, the IP address and prefix length, the interface identifiers, the connection type, the DLC for virtual circuits if there is any, the site-to-site VPNs if there's any, the routing protocols that it should have, your network, static routes, data link protocols, and the type of one technologies you are using in your network. Here it's an example using the same network topology but a different type of diagram. If you remember earlier, the physical network topology diagram, it's a diagram that involves only the physical aspects of your network. But if we see this other diagram, the logical network topology diagram, we can see it's different in several ways. How so? But again, it's here in this server, it's again the name, so you know what it is. But if you remember earlier, we had here the physical location of the device. Now we have the IPv4 address and its subnet mask. If we move on here we have that the cable type was connected to an Ethernet interface. Now we have the interface of the devices that this cable is connected to. And again, if we go here, we can see that these are the host, well, the identifiers of the device, the identifiers, the interface that is being used. Here we have the DLCIs, and so on with what we saw in here. All of this should be in your logical topology diagram. Now, we also mentioned a baseline performance level. In contrast with the previous documentation that we had, the baseline performance level, it's not something you can easily know what it is just by looking at the name. So a baseline performance level is a measurement, well, not a measurement, but a set of measurements from your network to know how are things happening. What do I mean by this? The baseline performance level establishes your network, your average network performance by collecting data from several ports and several devices inside your network. And this way you can see if your current network design can meet the business requirements that you have planned. And an important part here that may not be that clear, it reveals hidden problems. Now, what does revealing hidden problems mean? we can approach it in the next slide, which is what a baseline answers. What a baseline answers are the following questions. It tells you how is your network performing on an average day, as we said earlier. That is the main purpose of what a baseline does. Now, it can also tell you if you meet your identified policies, which we also mentioned. And this part is the one that one of the things that could be referring the hidden problems part. It's the baseline answer. A baseline can answer you the following question: what part of your network is being the most used, and what part of your network is the least used? Exactly what does this mean? It means that you can plan your network, implement your network, and believe you know what is happening across your network, but many things are happening that we can't always be regulating or seeing exactly what is happening on our network. So there is a chance that the things that we have happened to occur are not actually happening. If we planned that a serial interface was being used the most for traffic, we could see that it's actually not being the most used for the traffic that we planned, and that our traffic is flowing through other places that we hadn't actually foreseen that it would be happening. This is the type of things that a baseline can tell you, that you can plan things but not necessarily these things will happen. Also, a baseline can tell you what kind of errors are occurring, the most type of errors. And this last part, a baseline can tell you what alert thresholds should be set for devices that need to be monitored. This doesn't sound clear and it sounds a bit confusing, but I will be covering it in the next slides so it can be clear. So remember this part, the alert thresholds should be set for what alert thresholds should be set for devices that need to be monitored. This will be retaken in the next slides. Now, to plan a baseline, you have to follow 3 steps. The steps that you need to do before you actually make your baseline or start collecting data is the first part, to determine the type of data you have to collect, because you could just start collecting data from all your devices, all your connections, all your interfaces, all your cables, and yes, it will give you a lot of data to have in your hands so you can see exactly what is happening, but all of this data is not always necessarily useful. You can get just a lot of data, but not always the most important type of data that you need. You want to see what is happening in a switch, in a router, but only in specific parts of your network, not all of the devices. If you check all of the devices, it's going to be a really hard work to be checking it constantly. Now that you know what type of data you want to collect, you need to see which devices and which ports are involved in this type of data that you want to collect. Again, as I said earlier, you could just start gathering data from all ports on the devices, but it's not the best approach to do it. You have to plan exactly what do you want to collect and from where do you want to collect it. And after you know these two first things, you have to determine how long is your baseline going to last. Um, Again, using the example of a lot of data but a lot of not important data collected, we can see that if we establish a baseline duration of uh, let's say a year, uh, first of all, it's just going to take a lot of time to collect, and it will not necessarily tell you what is happening correctly on an average day on your network. You have to establish your baseline length, when it will be beginning and when it will be ending, making sure you're picking days where your network is supposed to have an average day, not on months or days where you know it's going to have peak days or low flowing and data days. You have to pick for, let's say, a standard, more than a week of length for your baseline and less than 7 weeks for the length of your baseline, because any less of that would be you couldn't get enough you wouldn't be able to get enough information from a baseline that lasted less than a week. And if a baseline lasts more than 7 weeks, again you may have excessive amount of information to handle. Yes, you could have a baseline that lasts more than 7 weeks, but that would be only on particular cases that you want to establish a baseline with a lengthier duration. The troubleshooting process, and pretty much what this chapter was intended to be about. As we can see, the troubleshooting process is also a 3 stages process, but if we can see in the diagram, it can be a cycling process. What is this process about? Again, I will just be mentioning it quickly, and then I will be getting into more detail about the stages. The first stage, you gather symptoms. The second stage, you isolate the problem that you think is happening. And the third stage, you implement the corrective action to fix this issue. If your problem is fixed, then you should document the solution and save the changes in the necessary devices. If your problem is not fixed, then you should undo everything you did on the action that you thought would be correcting the issue, and begin again the cycle of the troubleshooting process, again gathering symptoms, isolating the problem, and so on until your problem is fixed. Now, what is the gather symptoms stage? It's easy to guess. The gather symptoms stage is about determining which network components have been affected and how is our network comparing to the baseline. The symptoms may appear in several ways, not just one type of way. Your symptoms could appear in the form of alerts from the management system, console messages, and the most likely user complaints, because the users are always the first to know what is happening in your network and when something is not right. The next stage, the isolate the problem stage. This stage is about eliminating variables until a single problem or a set of problems have been identified as the cause of the symptoms that you gathered earlier. And the third stage, implement corrective action. Action is, as its name says, just implement the action necessary so that the problem can be fixed. Now, uh, it's important to know that the severity of a problem should be weighed against the impact of a solution. What does this mean? It means that if you establish that the problem is that you have a server that needs to be taken down and um, and be maintained out of line for several hours, and it's a peak day of your of on your network, then you could just wait until the business day ends, and at the end of the day then taking the server out of production, because it's more important that the network continues to flow correctly, yes, but if your network just stops running correctly for a long period of time, it's best to just let the network flow, not most efficiently, but flowing, instead of just cutting the network service from the root. That is what, well, an example of what the uh, severity of a problem weighted against the impact of a solution means. Now, there are several steps in the gather information stage, and just the first one is shockingly the gather information to gather information. Um, this is, as its name says, gathering information, how what is happening that should not be happening. The second step in the gather information stage is determine ownership. This means to establish if the problem happening is within our organization. If the problem is within our organization, then we can proceed to the next step. If the problem is happening outside our organization, then we should contact an administrator for the external system so we can know exactly what is happening and how could we fix or make less noticeable the symptoms that are happening. The next step is to narrow the scope. Narrow the scope means determining if our problem is a core layer issue, a distribution layer issue, or an access layer issue. This is, of course, assuming your network's architecture is established in this type of way. It should be established in this type of way for efficiency. And after you know if the problem is from core, distribution, or access layer, then you need to gather symptoms from the devices involved in this process. If it's an access layer, then you check. If it's an access layer issue, then you check the devices involved in the access layer and you start gathering symptoms from them. If it's an issue from the distribution layer, then you identify the devices involved in the distribution layer and start gathering symptoms from them, and so on. And this last step, I only mentioned it in the sorry, I only mentioned it in the gather information stage, but this final step is needed in all the stages of the troubleshooting process, in the gather symptom stage, the isolate the problem stage, and the corrective action stage. This is to document the symptoms. And I'm not talking about documenting the symptoms in all stages, but having documentation for what is happening, what you are doing. That way, if we come back here, that way here you gather the symptoms and document everything that's happening. You isolate the problem and you document how are you isolating the problem. Why did you decide that the issue was happening because of a certain thing and not the other? And then again the implement corrective action stage. Uh, well, you document if your solution was the properly, or if your solution was not properly for the um, for to solve the issue that is happening. This is not just because of um, an administrative issues, because the people tell you that you have to have documentation of everything, but it's also easier if you have a similar problem. Then you check your documentation and see this happened some weeks ago. We can check the documentation if it's the same problem happening again, or if it can relate to the problem that we had the weeks earlier. And that way we can save a lot of time and check what we did, what we thought the problem was, and uh, if the problem is similar, then we can implement a similar action that we used to fix that earlier problem. It's not the documentation part, it's not only administrative stuff, it's to make your life easier. And the isolating the problem stage. Here we have several ways to isolate the issue in a more efficient way. Here you can see the OSI model, and here we have three methods that we can use to properly isolating the issue. We have the bottom-up model. What does this mean? It means that we start troubleshooting from the physical layer. If there's nothing wrong, then we go up to the data link layer. And if nothing's wrong, then we go to the network layer, and so on until we find the issue. The top-down approach, it's the same as the bottom-up model, but it's in the inverse way. We start with the application layer, then if there's nothing wrong, we go to the presentation layer, and so on until we find the issue that is happening. And we also have the divide and conquer model. What does this divide and conquer model means? It means that we don't start at the top or at the bottom, but someplace in between, like the data link layer. We start troubleshooting at the data link layer, and if there's nothing wrong at the data link layer, then we can know for sure there is nothing wrong at the physical layer. This approach can be used not only must be used on strategical places of the OSI model. We start in the transport at the session layer, and again, if we check and there is nothing wrong at the session layer, then we can know for sure there is nothing wrong in the lower 4 layers, but the problem is somewhere in the 2 upper layers. There is also another type of approach that I didn't write here, but this approach is recommended only for experienced users, experienced network administrators. Not because it is very hard to do, but it's the contrary. You need a lot of experience to do this type of approach. This approach involves, in simple words, guessing where your issue could be happening. You check the symptoms, then you think the problem might be, for example, in the network layer. You check your symptoms and you think the problem might be a physical layer issue. This approach again is recommended only for experienced users because, as I said, they have enough experience to tell what is happening in a more efficient, well, not efficient but quicker way. And now we know how to troubleshoot. Now let's see how to monitor and troubleshoot the issues with tools. Here we have the common software troubleshooting, some common software troubleshooting tools. These are not all the software troubleshooting tools there are, but are the most common in the business. The troubleshooting tools are the network management system tool. The first one is the network management system tool. This tool includes a device level monitoring, and it helps you configure and have fault management. The host-based protocol analyzer is, as its name says, an analyzer. It analyzes network traffic, but more specifically the source and destination frames. So it's more focused in that area, in the source and destination frames. The Cisco iOS embedded packet capture. This this tool helps you provide traffic flow. Excuse me. This tool helps you see the traffic tracking as it is flowing through a router. In difference to the host-based protocol analyzer that focused on the source and destination frames, the Cisco iOS embedded packet capture focus on router flowing, on the information flowing through a router. Now the baseline establishment tool, you more surely know that it's for establishing a baseline. It helps you document tasks, draw network diagrams, and establish network performance statistics. And finally, the knowledge base are repositories of experience-based information. These are some tools, again not all of them, involving troubleshooting software. Excuse me. Some of the tools used in software troubleshooting. Now let's see some hardware troubleshooting tools. Again, these are not all of them, but the most common. We have the Network Analysis Module, or NAM. This is a it's a browser-based interface that helps you in the generation of graphic reports on the traffic that is consuming critical network resources. I'll say it again, the Network Analysis Module, or also called as NAM, is a browser-based interface that generates graphic reports on the traffic that is consuming critical network resources. We also have digital multimeters, or DMMs, that you already should know what they are about. Sorry. Next we have the cable testers. The cable testers the cable tester tests data communications cabling. They can detect broken wires, crossed over wiring, shorted connections, and improperly paired connections. These cable testers can be they can be inexpensive continuity testers or expensive TDRs, which is the next troubleshooting tool. What is a TDR? It's a um, it's a type of cable tester, yes, and its name means time domain reflectometers. TDR, time domain reflectometers. Sorry, and they can pinpoint the distance to a break in a cable. And they are like cable testers, but again more expensive, and therefore they should have more quality. It's I should also say that TDRs used to test fiber optic are known as optical TDRs, OTDRs. Then we have cable analyzers. The cable analyzers are multifunctional handheld devices that can be set to test and certify copper cables and fiber cables for different services and standards. Um, this is what most of them do, but again, if we get more advanced or more sophisticated cable analyzers, we can find some of them that can measure the distance to performance defect, that can identify corrective actions and graphically display crosstalk and impedance behavior. And most cable analyzers have a PC-based software, so we can see the results that is producing on the PC. The portable network analyzers. The portable network analyzers are devices that can be connected anywhere in a network. They allow you to see the switch port to which the cable is connected and the average and peak utilization. You can also say it can also tells you what is the VLAN configuration, identify the top network talkers, and analyze network traffic and viewing interface details. As the cable analyzers, most of them can have its output put in a PC, again with the proper software. And we have events logging. Events logging is, well, the logging of an event. Sorry. The events logging is events logging tells you what is happening that is not, let's say, normal in the network. Well, it can be something normal, but the events logins tell you whenever something is happening. The events logging can be sorry. Okay. The events logging can be set in several ways. Again, the events logging is how you know something is happening in your network, and the logs can be sent via console, which is the logging set by default, terminal lines that like console, they are only, its output can only be seen on the terminal line if it's terminal line, or in console line if you're in console, and both of these type of logins are not stored. They appear but not registered in anywhere. Now, buffered logging buffer logging does allow message storage, but only for a certain amount of time before they are deleted, or if you reboot the device, then all of your logins can be, well, will be deleted. um, SNM traps. This is the this has to do all of this has to do with the part I mentioned earlier in the performance baseline. Sorry. And these things have to do with the performance baseline that I mentioned earlier, where you have to set thresholds, and when the threshold was exceeded, yes, it notifies you. The SNM traps are thresholds that are pre-configured on the devices, and once you exceed those thresholds, they can be processed and forwarded to an external SNMP server. Again, because it involves a server, it involves also configuration and maintenance of an SNMP system. In the following slide, we'll see more about the threshold setting and configuration. And finally, the last type of event logging is syslog. And syslog is basically a client-server architecture, the most common type of logging, yes. And syslog can reside on many servers or many workstations, and it provides you long-term log storage and a central location for all the messages of your routers. And now let's see about these thresholds. The security levels. This is how you set these are the definitions and configuration for threshold setting. As we can see, there are 8 categories, 8 levels, 0 being the most critical one, and 7 being the type of logging that we are less interested when it's happening. And let's begin with the level 0 security level. Its keyword is emergencies, and as the keyword says, whenever an event with the level 0 security level is happening, it means that the system is unusable. The level 1 severity level its keyword is alert, and it tells you when it happens that an immediate action must be taken on what the log is telling you. The level 2 its keyword is critical. It tells you that critical conditions exist. Nothing is happening now, but that conditions are existing. The level 3 severity level, its keyword is errors, and it tells you that error conditions are happening. Nothing more, no critical conditions, but just error conditions, normal errors happening. Level 4, its keyword is warnings, and again, it only tells you that there are warning conditions happening. Level 5, keyword notifications. It tells you that everything is normal, but a significant condition just happens. And level 6, severity level, its keyword is informational, and those are pretty much regular messages that happen, informational messages only. And finally, the, let's call it, less important severity level, its keyword is debugging, and as the keyword tells you, those are only debugging messages. Below the table I put the configuration needed to set logging again for a for an external server, not only in your computer or router, or not computer, but on your network device. To set a threshold, you first need to, to set this type of logging, you need to first set the device that is going to receive the logins by using the login host and the IP address of the device that is going to receive the logs. Then you set the the logging trap level, let's call it command. For example, if you want to log only events that are critical and above, then you use the logging trap critical command. If you want to log only emergencies, then you use the logging trap emergencies command. It's important to know that once you set this command, all of the you will be storing all the events with the severity level that you set, and if there are any levels above the level you set, then also the events with higher level of severity, higher severity level will be stored. If you set logging trap emergencies, it will be only with level 0 events. If you set the level the logging trap notifications command, then you will be logging level 5, level 4, level 3, level 2, level 1, and level 0 events. And after you set the host and the level that you're interested, then you activate it with the logging on command. And now we'll be seeing some, again, common symptoms and causes for all of the layers involved in the OSI model. Let's begin with the physical layer and its common symptoms and common causes. What is happening that involves physical layer? Well, maybe your performance is lower than what the baseline told you. Perhaps you are losing connectivity, there are bottlenecks on your network, console error messages are appearing. What could be the cause of this happening? Well, it could be power related. Your devices are not receiving enough energy. It could be hardware faults, your cabling faults, your connections are not properly plugged in. There can be attenuation. If your cables are too long, then the longer it is, the more the signal is being lost across the wire, across the cable. There can be noise from the other devices, and and these are some physical layer symptoms and causes. Now we have data link layer symptoms and causes. Some symptoms are that there is no functionality or connectivity at the network layer or above. It can also be that your network is not performing according to what your baseline told you it would be. There can be excessive broadcasts or again console messages. This could be happening because encapsulation errors. Your packets are not being encapsulated properly. Framing errors. It involves something related. Address mapping errors. You're not sending it correctly to the not correctly. You're not sending it to the correct device. STP spanning tree protocol failure or loops. Something happened with your spanning tree protocol and there are loops happening in your network, causing that your packages are not achieving their final destination. Now we have in network layer symptoms and causes. Well, this is a bit more, let's say, simple, because if it's a network layer issue, then it involves, well, a network failure. I say it's issue because, well, it's a little more, well, let's forget I just called it easier and focus on what it is. Network layer symptoms and causes. The symptoms are that your network is not properly functioning. There is suboptimal performance. Why would this be happening? Well, if it's a network layer issue, it probably is because there are connectivity issues. Neighbor issues. The adjacency between your routers is not establishing. Therefore, your topology, your topology database is not properly, it's not the full topology of your database, it's just a part. And routing table, because something is happening, your routing table is not as you think it would be, and those are some causes of the network layer issues. Now, transport layer symptoms and causes. This pretty much is because of access control list configurations and network address translations configurations. These are the most common causes that can be why your network is having issues on the transport layer. And the most common ACL misconfigurations are that you didn't write the access control list entry correctly. You selected the wrong type of traffic flow that should be passing by or should not be passing by. Not only could it be that you put declared the wrong type of entry, but it could also be because of the order in which you declared your entries. It could be also because you're not taking in account the implicit denial that is after all your entries. Perhaps you made a mistake in the address and IPv4 wildcard mask in your entry. Perhaps there is something happening with the layer or ports that you selected. You didn't use the established keyword correctly. Those are some of the most common access control list configurations. Well, the NAT configurations, those could be a little bit trickier because of the nature of NAT. So we're not seeing that in full detail. But there is also another type of problems happening in the transport layer, and it involves the interoperability areas of the following sorry, of the following protocols: DHCP and bootp. They can have trouble issues, and it's happening at the transport layer. Also with the domain name system and WINS, SNMP, and your tunneling and encryption protocols. Something is happening. If something is happening because of that, it is a transport layer issue. And here we have the OSI reference model, and next to it the TCP/IP reference model. As we know, they have the same goal. They are differently structured, but they have the same, let's say, levels. It's important to know that if there is an application layer issue happening, it's not always necessarily because of something wrong the administrator do. As we can see here, the protocols in the application layer of the TCP/IP model are HTTP, Telnet, FTP, TFTP, SMTP, mail, DNS, NTP. If something is happening there, it may not necessarily be because of network administrator misdoing. Necessarily, it could be, but not always, because those are already defined protocols, and there could be something wrong happening in them. And that was all the information available I have for the chapter 9, Troubleshooting the Network, and I hope you had enjoyed it. Thank you for your time.